Today I'm going to look at LeetCode question number 853, car fleet. So there are n cars going to the same destination along a one-lane road, and the destination is target miles away. You're given two integer arrays, position and speed, both of length n, where position at index I is the position of the ith car, and speed at index I is the speed of the ith car. Okay. So a car can never pass another car ahead of it, but it can catch up to it and drive bumper to bumper at the same speed. A faster car will slow down to match the slower car's speed. Distance between these two cars is ignored. A car fleet is some non-empty set of cars driving at the same position and same speed. Note that a single car is also a car fleet. If a car catches up to a car fleet right at destination point, it is still considered as one fleet. And return the number of car fleets that will arrive at the destination. Okay. So, for example, here, if you have we just need to basically calculate how many groups of cars are going to drive bumper to bumper with each other and reach destination. So, for example, if you have like a super slow car here, okay, and this is our destination, and we have a car here that's way ahead, a car here that's just a little behind, and this is a little bit slow, but this is fast, okay, and this is like super slow. Eventually this fast car is gonna reach this slow car and slow down to match this car's speed. So, and then eventually this will, and so we count this as one car fleet. And this is counted as a separate car fleet because this car will never be able to catch up to these cars here. It will never reach them. So that's why we consider that a second car fleet. Okay, I'll try to illustrate this better with a graph. So I have an example up here. It's kind of a shorter example. I hope that will illustrate my point. Okay, so this is time and position, and let's say our destination is 10. Okay, so time is going to be like 1, 2, 3, 4. Okay, and positional, same thing, 1 to 10. Okay, now let's say we have these 3 cars here. So one car starts at position 0 and goes at speed 1. Okay. One car is at position 7 and goes at speed 3. And the last one is at position 8. And here's our destination up here. Destination target is 10. Okay. So for this very first car, it will take 10 seconds to reach our destination. Okay, I can calculate that using this equation. So target, which is 10 minus the initial position, which is 0, all over the speed, 1, will equal to 10 seconds, or 10 time units. Okay, so this will, not very straight. Okay, this will take 10 seconds to reach. What about the second car? So if we are at position 7 and it goes 3 speed units per second, so 10 minus 7, 3 divided by 3, which will give, it'll take 1 second to reach destination 10. Okay, so it'll take 1 second here. Hope I can draw this cleanly. Okay, what about what about the car position 8 with 1 speed? So it will take 2 seconds to get there. 10 minus 8 over 2, so 2 seconds. So take 2 seconds to get here, okay? Now notice these cars intersect at some point, okay? That means at some point these cars will meet and travel to the destination at the same rate, okay? So basically 8 is ahead of 7, or car position 8 is ahead of 7. It'll go along, and 7 is going along at a faster speed, and eventually it will meet the car at position 8. So what does it do? It slows down, and then they end up traveling as a fleet. So if we just move this line here, that was originally 7's speed to go to a destination here. So eventually it will slow down and its speed will level off to match car position 8's speed, okay? And this is how, this is one fleet. What about this third car here? What about this car here at position 0? It will never be able to match the speeds of the other 2 cars, and it will always lag behind. So this will count as one fleet, okay? A good way to organize this is to sort these cars by position. So, like for this guy here, position 0 is speed 1, and position 7 with speed 3, and position 8 with speed 1, okay? So, and then what we do is calculate their individual speeds. So this guy's speed here, or calculate, I mean, the time it will take to reach target. So this guy will take 10 seconds, this guy will take 1 second, and this guy will take 2 seconds. Okay? Obviously this car is ahead, and it will take 2 seconds, and this car that's behind, that while it will take 1 second, it's bottlenecked by this car here. It won't be able to go its full speed because it will be stuck behind this car. So that's why this counts as one car fleet. Okay? And we take this guy to be the bottleneck. Okay? So if there's a car, behind this one that takes half a second to reach a position, or to reach target, sorry, it will still be bottlenecked behind this car, which is at a later position, but takes a little more time to get there. Okay? And this car will count as one fleet because it's its own bottleneck, really. If there's any cars behind it, like I know this is like already position 0 here. What if we have like, I don't know, 6? 4 minus 6 takes 4 seconds. What if the car starts at position 6 and then therefore it takes 4 seconds? What if another car back here takes 3 seconds but starts at an earlier position, like position 0? It will get stuck behind this car, so one fleet. Okay? And that's how we're gonna go about it. Okay? Well, we'll look at the car here, take this as our bottleneck, and if there are any cars behind it with a matching or lesser speed, it will get stuck behind this car. But if there's a car with a slower speed, it will never catch up to this bottleneck here, so then it becomes its own bottleneck. And all the cars behind it with the matching or lesser speed will get stuck behind this car. So now to code this solution up, So the solution will take O of n log n time, just simply because we have to sort the array based on position. It's just very difficult to calculate the number of car fleets otherwise. So how am I going to do that? So I'm going to create a new array called position speed array. Okay, and in here I'm going to store tuples of one car, and that tuple will contain that car's position and speed. Okay, so for range append a tuple of position and speed for the ith car. Position for the ith car and speed for the ith car. Okay. And then what I want to do is sort by the position here. Okay. Dot sort. Okay. Because the cars that start behind cars that start at a position lesser than because cars that have greater speed but start at a smaller position will get bottlenecked by cars with a slower speed to start at a greater position. Okay. And then what I'm going to do here is after that I sorted the array. Okay. What I'm going to calculate is the time to get there. For each car. Okay, so for I in that, okay, time to get there dot append what I'm gonna calculate. So target minus that at 0 because there's a tuple where the first item in the tuple is the car's position all over the car's speed. Okay. And I want this to be float values. Just because they could be decimal values. I'll cast these two floats here. Okay, hope I got my brackets right there. So, float. Okay. No, I think it's better to separate it out actually. So, speed is equal to okay. And then what I'm going to append is float instead of speed. Okay. Yeah, I just want this in case this car is traveling at speed 2 and then the car is traveling speed 2.5. I kind of want that distinction there. Okay, and then what I'm going to do is simply iterate the array backwards. I want to go backwards to identify bottleneck first. So the initial bottleneck is going to be the very last position in the time to get there array. I'm going to assume that's so we already know that's going to be the furthest car, the car with the greater position. And I'm going to assume right now it has the slowest speed, but if it doesn't, I'm going to assume right now it has the slowest speed, and every other car behind it is bottlenecked by it. Okay, and car fleets is going to be initially 1. Okay, bottleneck is the very last element, car fleets initially 1. So for I in range 1, time to get there minus 2, going to start from the second last element because we already took into account the last element here. And iterate backwards. Okay, so if the time to get there, the position for car at index I is greater than our current bottleneck, have this be our new bottleneck, and therefore our new car fleet. And okay, okay, and otherwise, if the speed matches or is faster than that of bottleneck, it's gonna drive bumper to bumper with that bottleneck here, and then so we move past it, and then finally return car fleets. Okay, I'm going to try compiling it first, and this is O of n log n with O of n space, or int and triple load. Oh, it's supposed to be I. Okay. Okay, that looks good there. I'm going to use try out with the other test cases. Okay, and finally I'll submit. Okay, great. Thanks for watching.